Preslar. A little bit of background information. I attended North Carolina State University where I studied computer science. After graduation, I found this awesome company, Skookum Digital Works. Do we need to?
Yeah.
Where I began to pester anyone and everyone I could find until they gave me a job here. And without any further delay, I guess, let's go ahead and get started. Today we're going to talk about Go. So what is Go? Go is a rather new language that has been developed by a small company some of you may have heard of called Google. It was originally designed by three pretty well-known engineers. Robert Grismer, who developed Google's V8 JavaScript engine. Robert Pike, who's probably most well-known for UTF-8 encoding. And also Ken Thompson, the designer of the original Unix operating system. So those are three pretty well-known guys there, all developing this Go language at Google. So in a nutshell, Go is a type-safe language. So if you're not used to working in a typed language, what this means for you is that you will be declaring exactly what types your variables are, exactly what types of parameters your functions will take, and exactly what types of data your functions will return. Go is a compiled language, so unlike a lot of languages we use today, Go went back a step and went more towards C, where the language is actually compiled versus interpreted or ran in a virtual machine. Compiled language gives several benefits to you as a developer. First of all, it can do type checking for you at compilation time. So if you're passing around types, you want to ensure that the type of parameter you pass to a function is the exact type you're expecting. So in JavaScript, we catch ourselves all the time, if type of is equal to array, you're trying to ensure that you know what type of data you're working with. You don't have to do that with a compiled language because the compiler checks to make sure the types you're given are exactly the types you're expecting. Another huge benefit of a compiled language is you're compiling code down to the native language that your target platform is expecting. So you're actually compiling down to machine code, which is going to improve performance a lot. Lastly, you're going to see a huge benefit also because the compiler can do code optimization for you. So the compiler can check and look for specific code patterns, and if it detects one of these patterns, it can optimize that block of code to run a little bit faster for you. So Go is also a concurrent language. So threading and things like that, that's not new. It's not a new concept. But instead of including or importing another library to work with threads, it's built right into the language in something they're calling a Go routine. Really easy to launch. You just put the keyword Go in front of your functions and you automatically spin up a new thread to execute that function with. Also, unlike a lot of system-level programming languages like C, Go is garbage collected. This was a huge benefit to the language for the simple fact memory management or manual memory management can get tricky, and then when you're dealing with memory management across multiple threads, it gets even more complicated. So they decided to make Go a garbage collected language so that you can primarily focus on developing clean, well-written code instead of worrying about managing pointers and references to memory, things like that. So, types in Go. We have, the basic types, your booleans and your strings and your numbers. Also, a couple of other types pre-declared by the language, but today we're primarily going to focus on, like I said, booleans, which are of course true and false values. You have your numeric types. Go does not use a single numeric type to represent its numbers, unlike something like JavaScript. You actually have unsigned integers and floating point numbers, 8-bit integers, 16-bit, the whole 9 yards there. Strings, which are common across multiple languages. You know what a string is if you've worked in basically any language before. The types to pay attention to today are the types marked by the asterisk, and I don't really learn well by someone telling me how to do something. So today we're going to do some actual coding because I'd much rather show you how to do something rather than just, present a lot of slides to you that I've copied and pasted from the language specification guide. So let's actually get into some code. Now, I will say I'm going to be doing some alt-tabbing here. I'll be switching from my editor to my console so we can actually see the output of the program, okay? So we're going to create a new file here. And we're going to open it up. So to begin with, all Go source files begin with a package declaration. And for right now, all you need to know about a package is it provides a namespace for your source file. So we're going to declare a package, and we're going to say it's a package main. Now this package, main provides a pretty important piece here, which we'll get to here in a second. But like I said, just pay attention. Packages provide a namespace for which you can declare functions and variables and constants, all sorts of stuff that the package will use, all right? So next thing we want to do for right now is we want to import a package. So the keyword import here, basically what we're saying is we're telling the compiler to say, hey, I'm going to use this external package. It's not a part of my code, but it's code that someone else has written. So it's saying, hey, go grab this package and put it with my code because I'm going to be using it. So right now we're importing what is known as the funced package. And basically all that allows us to do is to format strings and print output, whether it be to a file or to standard out or wherever. That's what the funct package does. And to demonstrate it, we're going to create a main function. Now I told you to pay attention to the package main. Package main is where the Go compiler looks to start executing your code. So in the package main, you're expected to declare a function main, which is common across a lot of different languages. You see it primarily in C, C++, C#, Java. You always have a function main. That's where your program begins executing. So function main with inside the package main is where your program begins. So right now, just to show you, we're going to print hello world. Very common. So we want to run this. And of course we see hello world printed to the screen. Now, you see this example a lot, but it's not really showing you anything. So I've got a small contrived example that I've come up with. Basically, since the NSA likes tracking people, today we're going to basically write a small example of how that might be done so that we can help them out a little bit. And we're going to begin. So we need a person, obviously, because we're going to track people. So let's start by creating a type to represent our person. So we're going to say a type person, and a person can have multiple attributes. So we're going to say a type of a person is actually going to be a struct. And a struct, if you've never worked with a struct before in a language, or languages you work in don't have structs, a struct is just a data structure which holds various fields of data. It's very similar to maybe a JavaScript object, or I know structs are actually in Ruby, but or a Ruby hash maybe. So we're going to say that our person has a first name property, which is going to be a string value, and it's also going to have a last name property, which is a string. So now we know that we have a data type of a person. We need something to store a person in, so obviously we need a variable here. So let's create a variable. All right, and so in Go, we have several ways of creating a variable. The first one I'm going to show you is by pre-declaration. So I'm going to say variable John is of type person because we have to give it a type. And then we're going to say John is equal to a person with a first name of John and a last name of Doe. And then we want to print this output to the string. So we're going to print John. Let's run it. And we see we have John Doe printed. I don't really like the output to that. So a common technique here we all know when working with variables and different types of data, so we can add a toString method. So let's do that now. So we're going to create a a function which is represented by the keyword func, and we're going to say person. I'm going to say string, which is going to return a string. So there's several key pieces here. What we've just done is we've defined a function that's going to operate on a type. So this function string is going to operate on all types of person. And then once it's done running, it's going to return a value which is of type string. So once again, we want to return.
And the screen slowly to the right a little bit, or got a little bit cut off.
What's cut off? I'm sorry.
And just move the screen a little left to the right.
Drag your window.
Drag your window.
This way?
Yes, that's good.
Okay.
So we're going to return a string, and I told you fumpt is used to format strings, right? So we're going to use the fumpt package to do this. We're going to do fumpt.string print formatted. That's what sprintf stands for there. And we're going to say first name, and I'll declare this like this, first name. I'm going to use some data formatting variables here in our string, and then we'll say last name. We'll also use that. And then we're going to supply this, the first %s with our first name, or p.firstname, and our p.last name. Go ahead. Good catch. So now we've got this. Let's run that. And so we see that we printed our person, and it's formatted now. Still to the right. Better? Okay. So let's tab back in here. So now we have a person. What do we need to track this person? We're obviously going to need some kind of coordinate system. So let's set up a coordinates type. I'm going to say type coord, and we'll make it a struct as well. And we know that we need basically a longitude and a latitude value. And a latitude. And we're going to say that these types are, we'll say float 64s right now. So I told you earlier there's various numeric types in Go. We're going to use the double point precision floating number here for float 64. One key takeaway here is you noticed I put these struct fields both on the same line. So if we're working with fields of the same type, we can actually do that. There's no need in writing them on different lines as long as they're the same types. So we're going to say add to our person object and say that the person has a location which of type coords. Okay? And we'll come down here to our string, and we're going to say coords. We're going to say %v here. And we're going to pass p dot location. I know that's getting a little long, just bear with me. We're going to add another string method for our coords, and we're going to return. No, string is a function we're defining onto our object. Okay, so like once again, so we have a function here, and we're giving it what this is called is we're creating a receiver method. So we're saying this function operates on this data type. Okay. So once again, printf. We'll say %f, comma %f. I'm going to pass it c dot latitude and c dot longitude. So let's go back down to our main function. Now back to our variables. Okay. You'll notice here that I'm passing representations of our data directly into the struct type. Now, if you declare your variables in this manner, it's going to now throw an error at us because we're not passing all of the appropriate data to complete that struct type. So I'll go ahead and run that. You'll see it gives me an error because we're missing the coordinates field. So another way we can do this is we can say specifically what parts of the struct we're wanting to define. So we can say that our first name here is going to be John, and our last name here is going to be Doe. And you can see it prints, it actually works this time because we've said this is the data this is going to represent, this is the data this is going to represent, but now we're missing our coordinates. So we're going to say John.location is equal to a coordinate struct, and we'll just say he's located at 1, 1 for right now. So now we see that coords is set to 1.000 because it's a float 64 number, and his longitude and latitude are both 1. All right. So we have John. He has first name John Doe. We have his coordinates. Now we need to basically say, okay, we have his area, but we need to know where John's at. So we need another type. We need a location type. So let's go ahead and define a location. So once again, type location, which is a struct. And how do we define a location? Well, obviously, we need coordinates for the location, and we also need a radius. We'll make this float 64 just to stay consistent. So now we have a location and a person. We can we can basically begin here to figure out where this person's at. So we'll make another variable, and now I'm going to show you the second way of introducing a variable into your Go programs, which is called shorthand declaration. So up top here, this var John person, John is equal to, that gets a little long. So we can shorten this up by saying colon equal location and pass it coords. We'll say this is at 0, 0, and then we'll say it has a radius of 5. And we also want to print location. So now we're printing a location object, and we're also printing, so you see its coordinates embedded in the struct here, and also it has a radius of 5. So where do we go from here? Let's go ahead and, I don't like the way location is printing, so we're going to copy our string method here. We'll move it down, say L location, and we're going to print a string, and it's going to have a radius, which is a float, and a chords. So we're going to pass it a L dot radius and a let's say L dot location. Let's print that out one more time. So we're getting a little long here. I wish Go allowed us to how do I want to word this? To access the location, the coordinates of the location, we obviously have to say location.location. And then we can access its longitude and latitude properties. That's getting a little long. I don't really like that. So this presents a case where if we were using a classical, class hierarchy type language, we could basically extend the class and say location extends class coordinates. But Go is not a class-based language, but it does allow us to do something called composition. So instead of giving a locations field on each of our objects, we can basically take a structure that we've already made and embed it inside of another structure. So this allows us to do this. We can remove that location and we can access longitude directly off of our location property. So this is really important to see here, like Go is doing message delegation for us. Whoop. Find the field location. What am I trying to print here? This no longer has a location, this just has coords. I'm sorry. I'm still trying to print location somewhere. 20 and 29. So let's do this one more time. So there we go. So now if you see here, we are accessing a location's longitude. We're not going through a field type on the structure. We're going through an embedded structure. And Go is delegating that call for the longitude directly to the embedded struct. All right, so now we have our location. We have our person. We need to know, obviously, the distance between the two. So we're going to come up here, and we'll say we need a distance from function, which is going to be a receiver method on a coordinates. So we want to know how far the two distances are, or the two coordinates are from one another. So we'll say func c coords distance from, and we're going to pass it another coordinate. And we're going to turn a float 64. So for you all that maybe don't remember, what we can use here is the distance formula. Don't expect you to know it. I had to look it up myself. So the distance formula is the square root of dx squared plus dy squared. So we're going to import another package, the math package, to help us out here. Now, we could import this package like so, but I like to do things in as few lines as possible. So we're going to try to one-line this, and we're just going to use one import keyword to import multiple packages. So you see here, I've imported two packages, but I've surrounded both packages with parentheses. Go ahead.
Does the white space matter at all? Or do you have to have it on a blue line?
In certain cases, it does matter. You would generally want to, it's similar to JavaScript with automatic semicolon insertion. So we could probably put a semicolon here and do it like that. It's just generally, you don't really want to put them on one line. It reads easier if you break up the lines. Go is not a white space language. So it's not like a CoffeeScript or something like that where you're writing and it depends heavily on how many tabs you're in or anything like that.
And is person like a subtype of chords right here now because of what you did with composition?
Actually, chords would be, yes, that's what it's mimicking. So if you know like inheritance, so you know class A extends class B, that's basically what you're doing. Now, it's completely different. It's a really huge topic. It's documented really well in the language specification. But yeah, you're mimicking exactly that, okay? So back to our distance from, we're going to use shorthand declaration here. We're going to say dx is equal to math, not main, math dot power of C or O dot longitude, subtract C dot longitude. I'm going to raise it to the second power so we can square it. I'll make another variable, dy, and this here is going to be for the latitude, and we're going to square that. And then finally, the distance between the 2 points is the math dot square root. It's complaining about something, I think, of dx plus dy, and we want to return d. Let's make sure this still compiles, and it does. So we want to get the distance between our location and our person object here. So remember, we're embedding coordinates and we're getting that message delegation so we can access properties from a coord struct directly from anything that they're embedded into. So instead of saying location.coords.distance from, we can actually just say location dot distance from p dot coords. And we'll run this and we'll print it. Oh, it's actually John. So we're seeing John is 1.414. We don't have units away from the location. Okay. So now we know the distance between our two objects. Because we've declared it as a type of person, not a type chords. Remember, this is another key important fact. We're not extending a class, so it's not an interface. It's an actual person struct. So you're not getting that classical inheritance scenario where you can pass, this class has extended this class into that function. So no, you actually have to pass the chords into it. So now that we know the distance between the two, how do we tell if John falls within that location's radius? Well, that's just pretty simple. Let's make another receiver function, location, and we'll say contains. And this function is actually going to take a person, and it's going to return a Boolean value, true or false, whether the location contains the person or not. So how do we tell if a location contains a person? We have its radius. So what we'll say is if L.coords dot, actually we say distance from P dot coords, we'll say if it's less than or equal to our location's radius, we're going to return true because it falls within our radius. If it's not, we're just going to return false. So here we can say location.contains John, and it tells us true. That's expected. So let's go ahead and let's move John. Let's move him pretty far away, make sure we get false. So that happened. We got false there. That's what we wanted. So now we have a person and we have a location. Now we need a bit higher layer of abstraction to contain multiple people. So we're going to call that an area. So let's go ahead and make a type for an area. And we're going to say the type area is an array of type location. Okay, it's not a structure, it's just type area is an array of locations. So we want to see if an area has a person. We want to be able to locate the location. We want to see the location of the person. So what we're going to do here is we're going to say func a area, and we're going to see locate p person. And we're going to return a location. Okay. So how do we go about doing this? We know that area is of type array, so obviously we want to loop through all the locations we have in our array and see if that location contains the person we're looking for, and if so, we want to return that location because we found the appropriate location. So we're going to say for I shorthand is equal to 0, I is less than the length of our array. So len is a pre-declared function that you can use anywhere within your Go programs. It basically just returns the length, the current length of an array value. So it's just like saying array.length in several languages. And then we're just going to increment I based on that. So you notice here that unlike a lot of languages, we don't have parentheses around our for loops. These parentheses are not optional. You just don't have them. All right? So the same thing goes with our if statement. So now we want to check to see if the location, the current location in our array, so if a at I dot contains p, return a at I. So once again, you notice that we did not have parentheses around our if statements. These are not optional. They're just not there. So what happens if we don't find one of our locations in our area that contains our person p? Well, we can't really return nil because we've told our function we're going to return a location here. So we have to return what is known as in Go a 0 value. So a 0 value, if you're working with a numeric types, would be 0. If you're working with a Boolean type, it would be false. So basically, string is an empty string. So a struct, though, that's a special case because it has embedded fields in it. We return an empty struct or a 0 struct, which is just all of its fields have been zeroed out. So if you have an integer field in your struct, it's just 0. All of your Booleans are false. So we're going to return a location. So let's move John back to 1,1 so that we know he is in our location. And let's also create a new area here. We'll say area is equal to an area, which I've already said is just an array. So we're going to assign location as a member of that array. So then we could say area.locate. We're going to pass it John. And it should return our sole location. So this should print true here. So we have found the location within our area array that contains John, and it is the location we provided it. So what happens if we, once again, remove John from the area and set his coordinates way outside of it? We get false. That's not really good, though, because we still return a location. So as a developer, you're like, oh, I got a result back. You didn't throw an error. What's going on here, right? So how do we do this but still let the developer know something went wrong? Go does not like to throw errors, all right? You don't want to do a throw error and then try and catch. Instead, Go wants you to return errors, kind of like you would pass an error to a callback function in Node.js or something like that. So up top, we want to import our errors package, and we want to change our definition of locate. In Go, you can actually return multiple things from a function call. So we're going to say that locate does not just return a location, it also returns an error. So we need to change this. We need to say this error is nil here. So when we actually find a location, we want to return nil as the error result. And then when we don't find a location, we still want to return its 0 value, but we also want to return a new error. And we're going to say we failed to find person. So this mixes things up a little bit. If I run this now, it's actually going to throw an error for us. So we're returning multiple values, and you see the error. We're trying to use it in a single value context when it's returning multiple values. So what we'll do here is we'll make an if statement. We'll say if location, or just L here, L error is equal to area.locate John. And then what I've just done here is I've declared two variables that are going to be scoped to an if statement. So you catch yourselves a lot of times in languages trying to create a variable only to use it in an if statement, and then you just don't care about it anymore. So what Go allows you to do is actually create those variables and only scope them to your if-else blocks. So first of all, you always want to check and ensure that your error is actually nil in this case, because you always want to handle your errors before you do anything else. So if error is not equal to nil, we're actually going to panic here, or actually throw an error, which I said Go doesn't want you to do. But we're going to do it here just so we can show it off. So we're going to panic and pass the panic function an error. Else, we're going to print line the location that was returned, or L. So we're expecting to panic here because we've moved John outside of the area. And we see we're panicking with the error we presented, failed to find the person. So let's move John back into scope here. And we should get a valid location. All right, so we have these locations, but we want to get a little bit more specific with them. There's various kinds of locations. We don't want to give a location a name property. Instead, we want to define other locations that basically are composed of a location. So I know that's kind of confusing, but this is what we're going to do. So we have, what's a common location? We have a home. So we're going to have a home, which is a struct, if I could type. And it's just going to be composed of a location. We're going to have a office, which is also a struct composed of a location. And finally, because I kind of want a beer, we're going to say we have a bar, which is also a location. So we kind of need to redefine our area a little bit here. An area is no longer a BF type array of locations. Instead, we want a more generic storage structure. So Go is a type language. How do you get generics from it? It's easy. Go has the concept of an interface. So unlike other languages that implement interfaces, this is not a new thing. C++ has interfaces. Java has interfaces. Go's interfaces are really cool. So we're going to say we have a container because our locations are going to contain people, and it's just going to be an interface. And it's going to have to implement this interface, you're going to have a contains function which is going to accept a person and return a Boolean value. All right? So Go interfaces are implemented implicitly. So just like you don't extend classes, you don't implement interfaces. Go basically says it looks at all the receiver methods on an object and looks at an interface and says, okay, are all the methods here needed to implement this interface? Okay, they are. We'll let it be considered this interface. So we can change our area definition from an array of locations to an array of container interfaces. And then here, since we're no longer dealing with locations, we need to change this. We're going to return a container. And also, one last thing, the zero value of an interface is nil. So we can come down here to our area location, and we're going to change this to a home. And we're going to create an office. And lastly, let's create our bar. Let's change the coordinates up a little bit. Say our office is located at 2132 and has a radius of 10 because your employer never wants you to leave. And we have a bar, what's that, 40, 48, or 58 work. And then we want to provide these locations to our array object. Oh yes, that's a good catch. because that is how it's defined. So let's make sure that runs, and it does. We still should be getting back our home type here. Important to note about an array, or an interface. We're returning this interface container here, but we're returning a container. We don't know anything about a container interface other than it implements the contains method, which accepts a person and returns a bool. So if we come down here and we get our location, we can't do longitude because the program does not know that the location type has a longitude object. All it knows is it has that method contains. So we really want to get back the type that we were returned. So how do we do that? The first way I'm going to show you, it involves type assertion, which is just like this. So once again, we're going to use our if statement short declaration, and we're going to say if h, okay, is equal to, so we know we have L, and we're going to try to type assert it as a home. So what I've done here is I've told Go that I want to check to make sure that L is of type home. If it is, then our value OK should be true. And then we're going to func.println John is at home. And then we're also going to print home. But it could also be an office. Func.println John is at the office. I'm going to print the O. And lastly, else if B, okay. And then we're going to print the bar. So we see John is at home. That's what we wanted. Now what we've done is we've went through, we've converted our object from an instance of a home to an interface, and now back to a home, where we can then again directly access longitude and its latitude and everything about the home. So now we know exactly what type we're working with. We know exactly what types of fields are in that struct. We can continue using that as a home now. Now, if you're working with a bunch of types, it gets a little messy to have a lot of if, else statements. So Go has the concept of what is known as a type switch. So when you want to get the type of an object you're dealing with when you're working with interfaces, we're going to say switch L.type. So this is how you start your type switch. We will have a case for home, and then we're going to say John is at home. We also have a, I don't know why it's wanting to do that. Let's tab that back over, delete that. We have another case where John is at the office. And lastly, we have a case where John is at the bar. We see once again John is at the bar. So what we've seen here is we've seen classical inheritance represented as composition of objects. We've seen polymorphism through the use of Go interfaces. There's a lot of object-oriented design patterns that you can use in Go, but Go is not a classical object-oriented class-based language. So let's go back to our slides for a second. Let's make this full screen. Let's get all the way back through this. All right, so the last thing I want to talk to you about Go is, this is another reason why Go is actually really awesome. Go is a tool. A lot of times we argue over tabs and spaces and whether we do comma first or comma last. You don't have to worry about that in Go. Go provides a tool called Go Funct, which is automatically going to format your source code for you. There's no arguing over that stuff anymore. Go has this built right into the language. It's not a package you download. It's actually a part of the compiled binary that you download and install. Testing frameworks. We all love testing frameworks. We all love arguing over what one's better. Go has a testing framework built right into the language. You don't have to download any additional open source, dependencies. It's there. It's built into the language. Documenting. It's always really nice when developers document their code. Go provides tools for generating your documentation for you, as long as it's documented appropriately right above your functions, like you would see normal type documentation. It spits out the output, and you can literally take that as an HTML file and put it on the internet. So your developers will know exactly what kind of functions you're implementing, how it's implemented. Just document your code. It provides the tools for you. You might as well use it. Dependency management. No more bundler, no more NPM. Go has a dependency manager built right into its binary. To install a package, you just basically go get the location of your package. It can install from a Mercurial repository, a Git repository. Wherever the package is located, Go can get it and pull it down for you, and you can just import it and begin using it right away. Big thing about Go is there's no cyclic dependencies, so this package A cannot depend on package B if package A or package B already depends on A. So there's no going back and forth like this. It's a one-way direction only. And lastly, here are a few quotes from a couple well-known companies. First, Peter from SoundCloud. The language syntax is more, he describes it as a WYSIWYG language. So what you see is what you get. There's no questioning what is actually happening within the language. You can actually read it. It's pretty clean. You know what's happening as you're reading it. Standard packages in Go. A lot of times when I first started out with Go, I would catch myself trying to implement something that's already in the standard library. Really huge HTTP package, encodings packages. I know a lot of times, especially with a compiled language, you want to write a command line tool. You find yourself going out and trying to install some open source gem to manage your command line flags and stuff like that. That's actually already a package in Go. So as you're working with the language, if you decide you want to make a package, check the standard library first. Chances are it's already in there. So the standard library is huge. It's awesome. It's really well written, really well documented. You can go to the Go documentation website, and if you don't know how to use a function, you can look at the documentation. It's right there. It's really easy to read and understand. Like I mentioned with the dependency management, you don't have to worry about the dependencies in Go because they're managed for you. The dependency manager is there as a part of Go's core. So Go is a really awesome language. It's really, really, really fast. If you look at the benchmark numbers for it, it's right up there with C. It's not as fast, but you can actually use GCC to compile your code, or Go GCC rather. So there's a Go GCC that will allow you to do that. It's very, very comparable, if not beating Java in most implementations. Very, very comparable with Node, except for we all know Node is single-threaded, event-looped. We're not dealing with that. We're dealing with Go routines. So a lot of the benchmarks you see for Go that are compared to the V8 engine JavaScript, it's not really fair because Go can take use of threads where V8 can't. So Go is a really, really fast language. If you have a bottleneck in your application today, maybe go check out Go. Maybe try implementing that piece of your code in Go, and see if it doesn't help solve your bottleneck problem there. I hope you learned something. Maybe I hope I demonstrated the language properly for everyone. If I haven't, I'm sorry. I tried to give it a shot. Thank you all for coming out, and that's what I've got for you today.
What platform does it file for?
Go actually has x64, ARM, 86, compiles Windows, Mac, Linux. Standard library works cross-platform. For example, it uses dev-urandom for generating random numbers on Linux Unix systems, where it uses some other Windows-based solution for generating random numbers. So what Go code you write on Linux will run and compile on Windows, Unix, and Mac. But once again, you will get the native machine code for the target platform you're trying to execute and build on. Any other questions? Chadley.
So as far as movie applications go, is it like Java where they kind of provide their own weird UI, or is it kind of native control like Windows?
That's actually something that's an open source project right now. It's actually being developed by one of the actual Go developers. It's not a part of the standard library yet, but we might see that in maybe a few months.
So what are typical use cases right now?
For Go, really anytime, like I said, you have a performance critical piece in your code, you don't want to drop to C to write it because that can get a little messy, or maybe if you're not the greatest C programmer ever. Generally, you see a lot of people out there that will instead go to Go to write their web service or API that's really getting a lot of traffic. So anytime you have like performance critical pieces in your application, you see, like I said, Google Play. So the whole Play Store is served off of off of a Go server. SoundCloud, Heroku. They're all moving a lot of their performance critical pieces of their application into the Go language. Anybody else? All right, thank you guys. That's all I've got for you today.